Hey everyone, welcome back to MLWorks. In this video, we'll be discussing how to fine-tune a part of GPT-2 model. So we know that GPT-2 is a very large size LLM and it requires a lot of data to train on, and also it requires a bigger GPT to train on. So what we'll do is, instead of training the whole model or fine-tuning the whole model, we'll be just fine-tuning a section of it and test it out. So for this purpose, you can either use Colab environment or you can go ahead and use Kaggle environment, because both of them provide free GPU for you to use. And when it comes to the performance after fine tuning, it will be average or below average or very poor also, because we are just taking a section of the GPT-2 model. We are not taking the whole model itself. Okay, so the performance is not expected to be great. The whole idea is to understand the whole process of how to fine-tune a part of GPT-2 model. Okay, so with that introduction, let's jump on to the tutorial. So first part is installation, then downloading the dataset, then transforming the dataset into a format such that GPT-2 tokenizer can take it in, and then we'll tokenize that into token representation for the model. And once the model is able to accept that format, we'll fine-tune it and then we'll save the model and test it out. So with that, let's get started. First, pip install transformers and dataset for model building and a dataset for the data for the model. We are downloading the packages. This is already satisfied, so it won't take much time. So let me just hide this output. Now what we want to do is, since we have downloaded the packages, we want to import all the modules that are required for this tutorial. So we want to import the tokenizer, which is GPT-2 tokenizer, because we are trying to fine-tune GPT-2 model. Okay, so once we have that tokenizer, we have our head model, and then we have our trainer for create a trainer object, which will in turn train the model, and then training argument for how to set up the experiment for training. And then we load dataset for downloading the dataset, and then we have some dependency on torch and JSON. So let's import that. So while that is happening, let's understand what we'll do now. Okay, so first we'll download and transform data as question answer pair, as it is done here. And then we'll create one giant text file by combining all the rows. So this will keep giving you row. So what we'll do is, with the help of this function, we'll combine all the rows and turn it into a one text file, which is training dataset.txt. Now, once that is created, we'll be loading it as load dataset text data files is equal to dictionary of train given text file. Okay, this will create your dataset, which can be loaded and can be used by the tokenizer. So let's run this. So it has downloaded and it has split into train. And now what we'll do is, now we just have the text file, which is in text format. Now we want to turn it into tokens, which can be understood by the model. So we use something called as GPT-2 tokenizer. And since we want to, this tokenizer will be for GPT-2 model, we want to pull this specific model GPT-2. And then what we do is, we also add padding token to the tokenizer, which is end of sentence token, that is added as padding token. Now, once this is done, what we do is we create a tokenized function, and it will map this tokenized function to the dataset as done here, which is dataset.map, and you pass in the tokenization function and you want the batch to be true. It will create batches of your data input. Now inside this function, what we do is we take each example and we perform truncation. If the size of the input is greater than the model accepts, we'll do that truncation. Otherwise, if it is smaller than what the model input takes, we'll pad it. Okay, so we have whatever the text input also has a label. The reason why we are just copying that is because we are trying to build a generative model. Okay, so it has like no labels in general. So what we do is we take the input itself as the output. So this is where we do the tokenization and get our tokenized data set. So let me run this cell. So once that is done, what we do is we take our model head, which is GPT-2LMHead model, and which is GPT-2 from GPT-2. So this is a pre-trained model and it has some parameters which are trained on a certain data set. Now we'll download that aspect alone. Okay, so we'll download this model, and while that is happening, let's talk about the training arguments and the trainer. Trainer takes the model, training argument, and the data set. What is training arguments? It is the general set of parameters that you normally set for any deep learning model, which is the batch size, number of epochs, how you want to store your, during the training phase, how you want to store the model validation. So all those things are present inside this specific function. So let me run this as well. Now we have set up our trainer, we have passed our data set as well. Now we want to just kickstart the training. So we can just do trainer.train. Let me run it. So it takes kind of less time, just 3 epochs, so it won't take much time now. And we are not interested in how the results looks like, we are just interested in the process. So once the trainer is done, the training is done, we can go ahead and save the model, and we'll be saving trainer.save model, give the model name, whatever it is. So this is based on, I guess it is Star Wars Darth Vader dataset. So we'll be storing that as Vader underscore GPT-2. Now let me just save this. Okay, while it is getting saved, let's move on to the next step. Now earlier we downloaded GPT-2 model with the help of GPT-2LMHead model. Now what we do is, since we have already trained a model here, which is on this data set with the name Vader underscore GPT-2, it has been stored. We load that model now, and we load a tokenizer, GPT-2 tokenizer, which is again this one. We load both of them. Now to test it out, okay, so any input query which is passed by the user, it has to undergo a certain set of process. So first it has to understand what is the, we have to understand the tokens. So whatever the input you are giving, it has to be sent to the tokenizer, which will encode that prompt, whatever you are sending. It will return the PyTorch tensors, and that is your input IDs. Now based on these IDs, what we do is we try to create attention mask. So what will happen is, there are real tokens. For example, there are some components are present, or some text or words are present. So those will be ones, and there will be some tokens which are like not present, okay, which are not what I would say is if the input is smaller than what the model is requiring, okay, you pad the tokens, okay, those will be zeros. Okay, so this will end up creating attention mask. And what we are doing next is to generate the output. So we are taking a bunch of parameters, the temperature, number of top k elements, like top k next words that it has to look into, which is 50. What is the cumulative probability? We want to look at 0.95 is the cumulative probability. And what is the maximum length of the output, which is 100. So return sequences. So bunch of parameters are present along with the inputs and attention mask. So we pass that to model.generate and get our output. So this output is again decoded by the tokenizer, which is turned into a format which the person can understand, a human can understand. So we decode that and get our exact response. So let me run this. So the input is, did you remember to buy your ventilator filters? So in terms of the data set, when you fine tune it on a specific data set like Vader data set, okay, it would give most probably these kind of answers, okay, because it is based on that specific fine tuning, okay, fine tuning on that specific data set. So it is able to give this answer. But when you send this specific output, it is still able to answer, but the same thing. It always talks about what the character was there, right? The Darth Vader character, whatever it was. It is understanding that aspect and it's trying to fill in the next tokens. So with that, I'll be concluding this video. Thank you for watching.